So the first one is graphing. It starts pretty easy and then gets a little harder, I guess. The first one's graphing. It's already in y equals mx plus b. So you just have to find your slope and your y-intercept. My m here is -5. So I get -5 over 1. It's negative, so I would go down 5 to the right 1. And my y-intercept is at 8, so that is my starting point. Okay, so I start at 8, and then I go down 5 to the right 1. I'm going to graph it. Okay. We started at 8, down 5 to the right 1. So make sure, try not to miss these easier ones at the beginning. I know graphing isn't fun for some people, but it does start with the easy ones. Okay. I can go back or slow down on any of these or do more examples if we need to. Just let me know. On this one, same thing. It's just a fraction this time. So my slope is -2 over 5. So this would be down 2 to the right 5. And my y-intercept here is 2. So again, I'm going to start at 2. And then I go down 2 to the right 5. So I started at 2, and then I went down 2 to the right 5. I do in my pictures right there. I have the number highlighted, which number they are, and they will be in the same order on the test as well. All right, the next one is same thing, but it's not in y equals mx plus b. Technically, I think you could graph this any way you wanted to, but I think it's easier to move it to y equals mx plus b. So to get y by itself, I subtract x from both sides, so I get y equals -x minus 3. So my slope is the number in front of x, which is -1. Put it as a fraction to do rise over run. -1 over 1 would be down 1 to the right 1. And then my y-intercept is at -3. Again, that's where we start. So I'm going to start at -3, and then I go down 1 to the right 1. I started at y equals -3, down 1 to the right 1. Down if it's positive. I'm sorry. Down if it's negative, up if it's positive, always go to the right. The bottom number tells you to go to the right. That's why I change all of these to fractions. All right, the next one, if you have y equals a number, it makes a horizontal line. If you have x equals a number, it makes a vertical line, okay? So what you do here is you just start at -5, like y equals -5, and you put a point, and it doesn't really make sense to draw it this way because y equals -2 would be the same thing. So y equals -5, I believe, Alex, you got to put one other point. What this is really saying is that it doesn't matter what x is, y is always going to be equal to -5. If x is 5, y is -5. If x is -8, y is equal to 5, or -5. So it does not matter what x is, y is always equal to -5. So try to remember that. Like I said, if you get stuck, you go put a point at y equals -5. It doesn't really make sense to go this way, so you go this way. But if it's y equals a number, it'll be horizontal. If it's x equals a number, it'll be vertical. This is one of those ones that changes. Like, you may work the review one time and get y equals. You may work it the next time and get x equals. This one, sorry, I accidentally screenshotted this wrong in the last class, but this one, finding the x and y intercepts. Again, don't miss the easy ones here. Your y-intercept is at where it crosses the y-axis, so it's 0, 3, and your x-intercept is -3, 0. You don't have to write it in as an ordered pair. Your y-intercept is just 3, and your x-intercept is -3. This is, I'll go ahead and say this right now just to give you a second to write if you're writing. Computer math is not perfect, okay? So when you're taking the test or after you get done with the test, it will show you all the problems that you did and which ones you got right and wrong. if you think you deserve partial credit on a problem, just come tell me, okay? I'll give you as much partial credit as I possibly can. I can kind of tell whether you deserve it or not, but you just come up to me and say, hey, look at my number 6 for me, and we'll look at it, and I'll determine if you need partial credit or not. It's also computer math. I don't think Alex will let you type an ordered pair in here, but just to say if you did, if you typed an ordered pair in here, but the answer is actually 3, I'd give you credit for it. It's not going to let you do that, but that's just an example because computer math's not perfect. Do you have a question? Or?
I was just wondering, like, by the partial credit, would like you send a negative sign?
Right. So like if you like this is you have your scratch paper. I'm not going to require you to turn in your scratch paper. I don't think. But if you write stuff down on the paper, then I can easily like, oh, I put it in the computer wrong. Or if you do work a whole one of those problems like number 10 or one of those hard ones, number 9, and you just miss a negative somewhere and it happens to work out, I would give you partial credit for that. Okay. So there is only 12 problems, so that means they're all are worth like 8 or 9 points. So like it's easy to give partial credit when you have each problem's worth a bunch of points. I know some of you just don't want to talk to me because that's the way y'all are. That's fine. You're welcome to review the test at home too, and then send me and say, hey, will you look at my number 7 and 10? I might get partial credit, or I messed this up. And I can do that as well. I do not go through your test though, okay, to give you partial credit because it takes a long time to load each question, to be honest, and it would just take me forever. But if you tell me which problem to look at for you, I will give you partial credit. All right. The next one has to do with your x and y intercepts. So this one you actually have to find them using algebra. To find the x-intercept, you make y be 0. To find the y-intercept, you make x be 0. Okay, so on the first one, to find the x-intercept, make y be 0. I take 0 and put it in for my y. Negative 5 times 0 is 0, so I just get 6x is equal to negative 9. Divide by 6, and x equals negative 9 over 6. Technically, you can divide both those by 3 and make this negative 3 over 2. Okay? So that would be my x-intercept. There's an example, a perfect example of what I'm talking about. If for some reason, I think Alex would count it right if you put negative 9 over 6 in there. I think it'd still give you the points for it. But if it counted it wrong, like I obviously would probably give you full credit for that. This problem isn't testing you on reducing fractions, it's testing you on intercepts. So definitely skim through your test after you get done. All right, to find the y-intercept, make x be 0. So that goes to 0, so I just have negative 5y equals negative 9. Divide by negative 5, and y is equal to 9/5. Just leave it as a fraction, that's fine. And put it in there, okay? So to find the x-intercept, you make y be 0. To find the y-intercept, you make x be 0. Do the opposite. I believe the next problem is very, very similar, but we have to graph it using the x and y intercepts. So same idea here. To find the x-intercept, you make y be 0. So I do 4x minus 5 times 0 equals negative 20. Negative 5 times 0 is just 0, so you end up with just 4x and negative 20. Divide by 4, and x is equal to negative 5. That goes over here. So I put a point at negative 5 on my x-axis, because that is the x-intercept. And then go do your y-intercept. Your y-intercept, you make x be 0. 4 times 0 minus 5y equals negative 20. 4 times 0 is just 0. So you have negative 5y equals negative 20. Divide by negative 5, and y equals 4. So that is the point 0.04. And now I have 2 points, so I can graph it. So we have 0.4 and negative 5, 0. All right, next one is getting into the algebra. These may be the hard section for you. Or might start getting harder here at number 7. Oh man, my answer's still there. All right, so this one says to use substitution. Technically, Alex isn't going to know which way you do it, but it is easier to use substitution if you have a variable by itself. Okay, so since x is there by itself, I know that x equals all of this. So what I want to do is take that and plug it into my x. Okay, plug it into the other x. So I rewrite the equation on top, and instead of writing x, I write what x is equal to, and it's equal to 3y minus 6 plus 4y equals -5. So now this has all y's in it, so to solve this, I'm going to distribute. And I get 9y minus 18 plus 4y equals -5. Combine like terms, so I have 13y minus 18 equals -5. Get y by itself now, so I add 18 to both sides. And divide by 13, so y equals 1. Once you get one answer, plug it in. So I'm going to take that y and plug it in. You could plug it into either one, the top or the bottom one. On substitution, it's always easier to plug it into the one that's already solved for x. So I plug a y equals 1 into my y and figure out what x is. 3 minus 6 equals x. 3 minus 6 is -3. So my answer is -3 and +1. When you are doing these problems on the tests, she said, you mess a negative up. I do not believe you'll ever get a fraction on these. No one's told me any different when you're doing the homework and stuff. So if you get a fraction or a decimal on these, go back and check your work. There's probably a minus mixed up somewhere, or a negative or something like that. You should get an integer. All right, the next equation is, this one is not as fun to use substitution because you're going to deal with a bunch of fractions. So you want to use the elimination or the addition method. What do y'all want to cancel out, the x's or the y's? The x? You say y. It doesn't matter. Either one. Both one in each one. Like you have a positive and a negative and a negative and a positive. So that makes it easy. I guess this goes to 35. What would you want that to be? What, 15, right? So it might be easier to do the y's because you got 15. But you can do the x's. It doesn't matter. So we said we'll do the y's. 15. So on the top one, I want it to be -15y. And the bottom one, I want it to be +15y. All right? That would make it cancel out. And I did the negative on top because that one's already negative. So I'm going to multiply this one by, so let me change colors. Multiply this one to get -3y to -15y. I'm going to multiply by 5. So make sure you distribute that all the way through. 5 times 5x would be 25x. 5 times -3y would be -15y. 5 times -7 would be -35. Okay. And then on the bottom, I want to multiply by, I want to get 5y to 15y, so I'll multiply by 3. 3 times -7x is -21x. 3 times 5y is 15y. 3 times 9 is 27. Do not forget to multiply these last numbers, okay? You got to multiply everything in an equation by that to keep it the same. So now you add them up. 25x plus -21x would be 4x. -15 plus 15 cancel out. -35 plus 27 is -8. Okay. Then just solve this by dividing by 4, and x is equal to -2. And like I said before, once you get one answer, just plug it in. Does not matter which one you plug it into. Oh man, that's in my way. I'll plug it into the, the bottom one. -7 times -2 plus 5y equals 9. Plugging that x in, or -2 into x. So I get 14 plus 5y equals 9. Subtract 14 from both sides, and you get 5y equals -5. Divide by 5, and y is equal to -1. So -2, -1. And remember, we don't really talk about this much on the test, but that is the intersection of those two lines. That is the one point that is on both of those lines. That is what we're solving for. All right, so you got those two system of equation ones. Maybe that's the part that you struggle with. Go do those multiple times on the review. Graphing inequalities is basically the rest of the test. So you do this just like y equals mx plus b, just like we were doing on the first three problems. But there's two differences. If it is less than or greater than, you do a dashed line, okay, to signify that it does not equal the line. If you do less than or equal to or greater than or equal to, it is a solid line. And then since it is less than or greater than, you have to shade one side or the other. Okay? So start just like y equals mx plus b. My m is -1. So that's -1/1. I would go down 1 to the right 1. And my y-intercept is at -1. Again, I'm going to start at my y-intercept. My y-intercept is -1, and then I go down 1 to the right 1. This is a solid line because it is less than or equal to. You know, and I probably will want. Okay. All right, so we've done the one thing, the solid or dash. Now we have to do the shade. To shade, you might be able to look at it if it is in y equals mx plus b, which all your problems are. Well, one of them's not, I guess. You might be able to say, okay, it's less than or equal to, so I should shade below. But the algebraic way to do it, or just to make sure, plug in a point not on the line. I'm going to plug in 0, 0. Okay, when I plug in 0, 0, I get 0 is less than -0 minus 1. 0 is less than or equal to -1. That is false. Since that is false, I'm going to shade away from the point that I picked. Okay, so I shade on that side. I shade away since it's false. If it's true, I shade towards it, away, or false, I shade away from it. Next one, left my note there from last class, but you have -4x plus y is greater than -4. So we want to put it in y equals mx plus b. Be careful though, because if you put it in y equals mx plus b, anytime you divide by a negative, you have to flip the sign, okay? That's the one algebra difference between solving it like an equal sign. And there's definitely a variation of this on the test that if you ever divide by a negative, you have to flip the sign. So if you had like a -2 in front of this y, you'd have to flip the sign. So to get y by itself, I'm going to add 4x to both sides. So I have y is greater than 4x minus 4. This is what I'm talking about. Like if you had a -2 right here, when you divide by -2, you'd have to flip the sign. We don't have to divide by anything on this one though. So we just go through our steps here. It is greater than, so I'm going to go ahead and write dashed right here so I don't forget. My slope is 4, which is 4/1. That's positive, so I go up 4 to the right 1. Remember, if it's down, it's negative is down, positive, it's up. I always go to the right, whatever the number on the bottom is. Then my y-intercept is at -4. That is where I'm going to start. So I start at -4, and then my slope says to go up 4 to the right 1. And this is going to be a dash line. Again, I know I said the partial credit thing, but like, if you graph the line right and you shade it in the right direction and you just forget to do dash, tell me. Alex probably give you a 0 and I'll give you some of the points back because you did a lot of the problem right. All right, to shade this one, it's greater than. When it gets more vertical, it's hard to tell which side is greater than, so definitely make sure you plug in a point. So if I plug in 0, 0 to this one, I like to plug it into the original because it's just easier. It works out easier. Because when I plug in a 0 on the left side for the X and the Y, I get 0. Is 0 greater than -4? Yes. So that means I'm going to shade towards 0, 0. So I want to shade over here. Oh, man. Okay. True, you shade towards the point. False, you shade away from it. Well, that's number 11 already. See, I told you it'd be quick today. And then number 12 is a system of inequalities. This one you have to graph both of these on the same line. So we'll make this one blue. This is going to be dashed because it's greater than. It's already in y equals mx plus b, so my slope here is -4, which is -4/1. So I'd go down 4 to the right 1, and my y-intercept is at -7. So I start at -7. Whoops, that's -9. -7. And then I go down 4 to the right 1. And this is going to be a dashed line. So to shade this one, again, we could pick 0, 0. 0 is greater than -4 times 0 minus 7. So that goes to 0. Is 0 greater than -7? Yes. That means I shade towards 0, 0. So I'm just going to put a little note. I know you can't really draw on your computer like that, but if you just write something like shade right side. Okay. So just a note to know that I'm going to shade on that side. All right, let's do the other one. So again, this is going to be dashed because it's less than. My slope is 2. So that's 2/1. I would go up 2 to the right 1. And my y-intercept is at 5. So I start at 5. I go up 2 to the right 1. Dashed again. And to shade my red one, again, let's plug in 0, 0. As long as it doesn't go through 0, 0, you can plug in 0, 0. So 0 is less than 2 times 0 plus 5. Is 0 less than 5? Yes. So I'm going to shade the right side of that line. I shade towards 0, 0. So I need to be to the right of the blue line and the right of the red line. That looks like it's over here. That's it. That's the 12 questions, right?